Okay, so we've got to finish up our notes here and we're looking at bone fractures. Okay, so I'm going to flip the page and we're going to talk about, so imagine a bone fracture. Probably what you're going to have, just a fancy way of saying a hematoma. So this is probably going to rip or tear, okay, the periosteum on the outside. And a hematoma is a blood, um, like a blood clot, and there's probably going to be some inflammation, which is probably swelling around that area, probably a pooling, okay? And so with that being said, I'm kind of thinking about this picture that you can see in your book on page 137. So you can see the hematoma out here. This is a tear. Again, I'm not sure if the periosteum will tear or you could get some sort of internal fracture. That's why I wanted you to do some of the research behind that. And again, this is located right here in this picture. This is located in the diaphysis. So you can see compact bone. There's some marrow in there, but it would just depend. It could be in an epiphyseal break, but in this case, it's right in this area. And then what you're going to start to see is very similar to how we started the primary ossification center. So you will start seeing, because there's such great blood supply, so we have our friends, the osteoblasts will start to come in and build again with spongy bone, okay? And when you think about the spongy bone, also we got to add in there our friend, the fibrocartilage. Oops, cartilage. Okay, I don't know what I just wrote there. Cartilage. Okay, so we're going to start to use a little bit of collagen. Okay, we're going to we're scaffolding it up. We're trying to put a patch on it. Okay, in order to get it shored up. Okay, and we're going to have our friends, any phagocytic cells, which we know is already in the bone matrix, like macrophages that are there are going to help clean up any debris, along with any osteoclasts that need to clean up the spongy bone so that we can deposit the compact bone, okay? So in this case, okay, if you see, so it almost forms this cartilaginous callus. So you've heard of calluses, remember that we have calluses on our hands? So it actually forms like a cartilaginous callus first and then is replaced by bone tissue. Very similar to the the primary ossification center. Okay. Remember that you can get in your book, granulation tissue can develop. That was from skin, of course. So any bone fragments that are in there will be cleaned up by the osteoclast. And it says, in time, fibrocartilage fills the gaps between the ends of the broken bones, and it's a cartilaginous callus and is later replaced by bone tissue in much the same way hyaline is replaced in the developing endochondral bones, okay? So if you notice, see how this is a much larger area, okay? Much larger area, and so the likelihood of you breaking it in the exact same spot is probably very small compared to any other spot, okay? So let's go back, let's get rid of this. And we're talking about this cartilaginous callus, which is from the fibrocartilage, okay, will then be replaced into the bony callus, just like endochondral bones, okay? And again, all is that really made possible because you have such a great blood supply, okay? All right, this is kind of just doing our own little cleanup here. The next part was bone function. So the physiology, support, and protection, of course. In your textbook, it really talks about how we form, it's a pulley system, pulley and a lever system on page 138. with your bones and your muscles. Another job besides support and protection is called hematopoiesis, which that's your bone marrow. So remember, the red bone marrow makes, you already knew this, red blood cells, white blood cells, and platelets. Okay, and again, I talked about this, that in young people, it's in most bones, and in adults, it's just found in the flat bones and the epiphyses. Okay, just in the ends. Okay, the yellow marrow is a storage of fat. Okay, that does not mean that someone who's fat has big bones. That is not what it means. Bone marrow transplants. I am not going to show you a picture, though I'm sure you could find a picture online of a bone marrow transplant. They usually use a hollow needle. It's more than just a blood type match. Okay, it is going to be more of a sibling, a genetic match. Okay, the recipient is going to have to go through some sort of chemo to kill off their bone marrow. Okay. All right. And last sort of cleanup that remember we have, so remember how I asked you to think about the organic components and the inorganic components? Well, one of those inorganic components is really talking about the salts and stuff that are found. And I said that hormones also control the absorption of calcium. So what can happen is that when your calcium gets down, a gland, an endocrine gland called the parathyroid, which is on top of your thyroid in your neck, says to the osteoclast to break down bone in order to need calcium. So which is why then we get osteoporosis, which is a weakening bone material caused by low estrogen levels. Low smoking adds higher risk, all of those things. Not getting exercise, body mass index over it. It just adds a whole pile of different things that osteoporosis just adds. All these different risk factors that are added to causing osteoporosis. Okay, and don't forget about knowing all of your bones. I do want to mention the axial and the appendicular skeleton. On this page, here's a great example. Your axial skeleton is everything you see in this brownish color or orange that you see. So skull, rib cage, and vertebra. Skull, ribs, vertebra. So think about, except for the clavicle, okay, and the scapula, okay, not clavicle and scapula. It would be what's hanging up in my classroom, okay? The appendicular skeleton is all the limbs, okay? Now they do give you two things that I want to mention off from the appendicular skeleton that they always, and it would be the pectoral girdle, okay, because that is something that's always mentioned, which is scapula and clavicle. Clavicle, there we go. And they also mention the pelvic girdle. Oh my goodness, my spelling. Pelvic girdle. That's actually the pelvis. So I guess we can't count the pelvis as part. So really, the axial skeleton is just head, vertebra, which includes the sacrum, okay, and ribs. There, that's it, okay? Whereas in the appendicular skeleton are the arms, okay, and the pelvis and the legs. Okay, there you go. Got some legs there. Okay. And we're going to talk more about the organic and inorganic on Monday. All right, thanks.